Number 79. The lattice energy of lithium fluoride, which is LiF, is 1,023 kilojoules per mole, and the lithium fluorine distance is 201 picometers. Magnesium oxide, which is MgO, crystallizes in the same structure as LiF, but with a MgO distance of 205 picometers. Which of the following values most closely approximates the lattice energy of magnesium oxide? So is it 256 kilojoules per mole, 512 kilojoules per mole, 1,023 kilojoules per mole, 2,046, or 4,008 kilojoules per mole? Explain your choice. Okay, so the first thing is I'm just going to rewrite these as just numbers along the, across the board. So 256, 512, 1,023, 2,046, and 4,008. And I'm just going to put out that the lattice energy of lithium fluoride is 1,023. So this number, right smack in the middle, is for LiF. And they did say that the lithium fluoride distance was 201 picometers. Now, we just need to figure out, well, what is the lattice energy of magnesium oxide, right? Is it going to be the same exact number as lithium fluoride? Is it going to be lower or is it going to be higher? Well, let's just analyze a little bit. Now, the lattice energy is basically the amount of energy needed to take in this case, LiF, and turn it into its ions. So when you break up the lithium from the fluorine, you get Li plus 1, because it's in group 1, and the fluoride ion, which is a minus 1. And the lattice energy specifically is all gases all around. So gas, gas, gas. Now let's just do the same thing for the magnesium. So MgO will break up into magnesium plus oxygen. And magnesium is in group 2, so that's a plus 2 charge. Oxygen is a minus 2 charge because it's in group 16 or 6A, and gases all around. Now, they did say that the radius for LiF was 201 picometers, and the distance between magnesium oxide was 205. And maybe, let's just throw this in the middle. Okay. Now, I did write down here the two things that really matter when you're changing lattice energies. It's either going to be linked with the atomic radius, right, and how close those ions are, or it's the amount of electrons that are transferred from the metal to the nonmetal. It's the actual electrons transferred in the ionic bond. Now, the first thing is that I see that for lithium fluoride and magnesium oxide, between those ions, the radius is basically the same. So I'll say similar. Radii. Plural for radius. So if you have similar radii, that's not really going to change your lattice energy. Only when you see a complete drop in atomic radius will that lattice energy rise if we're dealing with a positive lattice energy. But now, the only thing that matters here is how many electrons are transferred from the metal to the nonmetal. Well, it all comes down to those charges, the plus 1, the minus 1, the plus 2, and the minus 2. Now, you just have to look across the cation, which is the positive, and the anion, which is the negative. Lithium gained 1, or actually lithium lost 1 electron. And I'll put the 1 electron here. Magnesium lost 2 electrons because it's a plus 2. This is basically 2 times more. Going from a 1 to 2, that's 2 times the amount. So I'll put 2 times the amount. Fluorine had a negative 1, so it gained the 1 electron, but oxygen gained the 2 electrons. If we're looking at it across the board, 1 to 2, that's also a 2 times increase. You have 2 2 times increases. So you got to just times the two numbers together. 2 times 2 is roughly about 4, which means that MgO, just according to the electrons, should have 4 times more the lattice energy. Mainly because the more electrons that are transferred, 2 is greater than 1. The more electrons that are transferred, the more the lattice energy. So we're looking about roughly 4 times more than what the lithium fluoride was. And the lithium fluoride was roughly 1,000. So 1,000 times 4 is roughly 4,000. So I'm going to not shoot the 2,000. I'm going to go straight to the 4,000 because of those 4 times amount of electrons that were being, interacted with. And this would be for magnesium oxide. And that is the final answer. Hopefully this helped. Thank you so much for viewing the video. Subscribe to the channel, and I look forward to helping you with more questions. We also got physics and math videos on the channel, so maybe we can help you out with those subjects as well. More subjects to come, so always keep checking back on the channel. Love to hear from you guys, and I hope you're doing well. Talk to you soon. Okay, bye.